Hey everyone, and welcome to this Forge College Explainer. So, if you've been following along in our EVM to SVM migration track, let's be honest for a second. Your development workspace right now probably looks a little bit like a mad scientist's laboratory, right? Well, today is the day we take that Frankenstein's monster of disjointed scripts, environment variables, and tests from our last CI/CD lesson, and we assemble it into a sleek, fully automated Solana machine. We are delivering the full migration today. We're taking every single thing you've built and packaging it into one pristine, review-ready Anchor repository that perfectly mimics your old Hardhat or Foundry workflows. Let's get right into it. Okay, let's take a quick look at today's master blueprint. We'll be hitting 5 crucial phases: the grand final assembly, your blueprint for success, building the machine, verifying your setup, and finally, wrapping up the capstone.
Starting off with Section 1, the grand final assembly. It's time to actually put all these pieces together.
So, let's survey the components currently scattered across our workbench. You've been forging these individual gears throughout the previous modules. You've got your migration audit document, your Anchor scaffold complete with those localnet parity configs, your perfectly ported test directory, and of course, your CI workflow templates. Now it's like a giant puzzle. You've built the pieces one by one, and now it's time to stitch them into a single deliverable Anchor repository. This final repo absolutely must give you that same comfort and predictability you had with Ethereum, just heavily optimized for Solana.
Moving right along to Section 2, Blueprint for Success, let's talk about the Capstone acceptance criteria.
Before we tighten a single bolt, we really need to establish what a passing grade looks like here. Notice how we've divided the goals. Your primary requirements, those are non-negotiable. They guarantee absolute automation and documentation. We're talking CI builds passing with an exit code of 0, automated deploys spitting out a real project ID, meticulous doc mapping, and rock-solid release gates. You have to have these. On the flip side, the secondary criteria, things like consolidated scripts and local reproduce commands, that's what gives your project that brilliant professional finish. Basically, it's the difference between a car that just manages to drive and a luxury car with heated seats and a flawless paint job.
All right, Section 3, Building the Machine. Let's hit the actual assembly line with these 6 implementation steps. We have 6 exact steps to execute chronologically. Number 1, normalize your layout. Make sure your README, your anchor.toml, and your tests are exactly where they belong. 2, integrate that CI workflow YAML. 3, implement a unified ci.sh script for clean deployments. 4, add a verification script to prove the deploy actually worked. 5, map your docs explicitly. And finally, step 6, a little sprinkle of AI magic to clean up the rough edges and refactor everything. Now looking closer at step 2, this is absolutely crucial. You need to ensure your GitHub Actions YAML snippet includes these specific jobs. You've got to have checkout to grab the code, set up Rust for your compiler, build Anchor to compile the program, run tests to validate your logic, and deploy staging. By keeping these jobs totally isolated, if your pipeline breaks, you'll know exactly which gear in the machine just jammed. Honestly, it will save you hours of frantic debugging.
And for step 6, we get to unleash something I really love called vibe coding. Think of vibe coding like treating an AI as your super eager, lightning fast, but occasionally easily confused apprentice. You use AI prompts to basically duct tape redundant scripts into a single, clean entry point. It's incredibly handy for taking, say, 3 messy bash scripts and having the AI elegantly merge them into one beautiful c.sh file. But hey, pro tip, save the prompt you used. Reviewers aren't mind readers. They need to see your thought process to give you full credit.
This perfectly illustrates the documentation mapping we talked about in Step 5. You absolutely cannot leave your reviewers guessing here. You have to map those old EVM workflows straight to their sleek new Anchor equivalents. If an Ethereum dev is used to typing npx hardhat compile, you need to explicitly show them that over here in Solana land, we use Anchor built and tell them exactly which CI job runs it. You're basically building a translation dictionary for anyone jumping into your codebase.
Which brings us to Section 4, Verifying your setup. Let's run through the checkpoints.
Because look, at the end of the day, this is the ultimate question standing between you and a finished migration. Did it actually work? Is this thing going to hum like a sports car, or is it going to crash spectacularly on the launch pad the second we push to main? Let's check the telemetry.
Checkpoints 1 and 2 are your primary engine indicators. First up, we verify that your CI builds properly with an exit code of 0. In engineering, 0 means hero. No errors, all tests pass. Second, we verify that your automated staging deploy actually did its job. That means your script successfully initialized accounts on the cluster and spat out a real live Solana program ID right there in your CI logs. If you're missing that ID, Your program is basically a ghost.
Next, checkpoints 3 and 4 ensure that the human element is totally satisfied. We need to confirm every single Hardhat or Foundry command is mapped in your docs. And this is vital. We ensure reviewers can run a local verification script, like verify.sh, that connects to the cluster, checks the state, and proudly prints verification passed right on their local terminal. It proves to the world that your pipeline doesn't just work magically in the cloud, it's reproducible anywhere.
Finally, Section 5, wrapping up the capstone. Let's look at our final takeaways.
So if all those checkpoints are turning green for you, huge congratulations. You've successfully engineered a full migration. But as you prepare your submission, keep these golden rules etched in your brain. Keep your CI jobs small and focused so you can spot failures instantly. Make your deployments idempotent, meaning you can run that deploy script 10 times in a row without accidentally scrambling the state. And make sure they're securely gated. Document those EVM to SVM mappings like your life depends on it. And yeah, save those AI refactor prompts.
So what comes next? Now that your pipeline is officially migrated away from Hardhat and Foundry and safely over to Anchor, our very next lesson is going to be incredibly fun. We're going to tackle porting ERC token behavior right into Solana paradigms. We are literally moving from workflow infrastructure into the actual physics of tokens. It's a real game changer.
This explainer was brought to you by Forge College. I highly encourage you to head over to forge.college for more deep dives into Web3 and to continue this learning track. But before we sign off, I want to leave you with something to chew on. Now that your pristine, automated CI/CD machine is finally built, is it truly ready to handle the chaotic, highly complex physics of custom token standards on Solana? We'll find out next time. Happy building!